We're going to start looking at the ellipse today, and you're going to need your conic sections flip book for this. Alright, on that first tab, the important information. Here is the first half of our information, so you want to make sure that you give yourself enough room to write all this down. And the first thing is an ellipse. It's a set of all points x and y, such that the sum of the distances between a point, P, on the ellipse and two distinct fixed points called the foci is constant. And I'll show you a picture of what that means in just a little bit. And then the focus, well, when it's plural we call it foci. So a focus is a fixed point that's inside an ellipse, and that's one of those points that we use to make our ellipse. The vertices, those are the points on the ellipse where a line passing through the foci will intersect the ellipse. I'll show you what those are on the picture also. And then the major axis, that's the line segment that's going to join those vertices. Okay, the next set of vocab, this is the last vocab that we have under the important information. The center, that's going to be the midpoint of that major axis. Your co-vertices, those are the points on the ellipse where the lines perpendicular to the major axis and goes through the center intersects the ellipse. And I'll show you a picture of that in just a minute. And then the minor axis, that's the line segment that's going to connect our co-vertices together. Alright, go into our first equation. This is the x minus h squared over a squared plus y minus k squared over b squared. Now, this is always set equal to 1. That's a critical point when you're working with ellipses. And then remember, we have that little side note that says the a squared term is always bigger. It doesn't matter if the a squared comes first or comes second. What matters is that to use this equation, the bigger term has to be below your x variable. Now, the first definition of an ellipse said it's the set of all points such that the sum of the distances between a point P and two fixed points is called the foci. I'm going to do a sketch over here. You don't need to have this sketch, but just so you know what that definition is talking about, let's say these are my two foci. I'm going to call it F1 and F2. When it talks about the sum of the distance from these points, let's say the point on one of the points on my ellipse is right over there. The distance from my focus to my point P, let's call that D1, and then the distance from my second focus to P, we're going to call that D2. Now the sum of these distances, let's say D1 plus D2, let's just say that it was equal to 10. Okay, when I come over to a different point on my ellipse and I find my distances, what's going to happen is that we're going to call this long blue line D3 and the short one D4. What I can guarantee is going to happen is that D3 plus D4 is going to be equal to 10 because that sum of the distances has to be constant. If I did a third point and looked at the distance, let's say I called that D5 and D6. Well, when I add those two distances together, D5 plus D6, in order to be an ellipse, has to be 10. So that's what they're talking about when they say that the sum of the distances between the point and these two fixed points is going to be constant. Whenever we add those distances together, it's going to give us a constant number here. Okay, now this picture is the one that you need to draw on the top of the flap for this equation. And what we're going to do is we are going to start with sketching in our focus. So we're going to put two dots in there. We are going to put a center point in there. And then our major axis is the line segment that joins the vertices. And it's going to go right through our focus and right through our center. Right here are going to be our vertices. And then our minor axis is perpendicular to our major axis and goes through the center. So it's going to go right here. And that's where we're going to find our co-vertices. Alright, so if we go back through and we name all these. co-vertices, vertices, our center, and then our focus. Notice that we have just about 2 of everything except for our center. Our center is only 1 point. Okay, the line that's attaching our vertices, that is our major axis. So we need to label that one. It will always be the longer one. The other line we have here, that's our minor axis. And it will always be shorter than our major axis. Then a couple of different distances that we're going to get into here. First thing, our center, just like it was with circles and our vertex with parabolas, our center is at HK. So that's going to be kind of our starting point for everything. Now the distance from our center to our vertex is A. And notice that A comes from the denominator of our number with the x. Then the distance from our center to our co-vertice, that's going to be a distance of B. And notice that B comes from the denominator of the value that's with our y value. And the distance from our center to our focus is C. And we are going to put a little side note here where you get C from, because if you look in our formula up here, there is no C. Everything else is in our formula. We have H, we have K, we have A, we have B, but C we don't have. And in order to find C, you have to remember that for an ellipse, C squared is equal to A squared minus B squared. So it's very close to the Pythagorean theorem, but not quite. So that's how we end up getting this value of C. So make sure you get that diagram sketched and all of those points marked. Okay, now on the bottom of that flap, we want to go ahead and write down all of the important information that we have. And we are going to start with our center. Our center is at H comma K. And remember, you have to remember that note that you use the opposite of both H and K. Okay, the next thing, the length of our major axis. If we go back to our picture here, I told you that the distance from my center to my vertex was a distance of A. Well, my major axis is from vertex to vertex. So I'm going to go A over here and then A over there. So the length of my major axis is actually going to be 2A. Then my minor axis is going to be the same concept, only it's going to be B. So the length of my minor axis is going to be 2B. My vertices, if we go back to our picture, to get to my vertice, I have to go from my center A units out, either to the right or to the left, in order to get to my vertices. Now notice we have 2 vertices, so we have 2 different equations. And when I move to the right or to the left, I'm changing my x value. So if I start at H, I have to add A or subtract A. So for my vertices, I'm going to have H plus A, comma K, and H minus A, comma K. My co-vertices, a similar thing is going to happen. From H and K, I have to move up and down, so I'm going to be changing my y values. Well, I have to change it by an amount of B, because it's B units from my center to my co-vertice. So I would have to add B and subtract B from my K. So my co-vertices, there's going to be 2 of those also. It's going to be H comma K plus B and H comma K minus B. And then for our focus, I'm going to have you write down that little note again that C squared is equal to A squared minus B squared. And then in order to get our focus, from our center, we go a distance of C to the left and to the right. So we're going to have to add and subtract C, and since we're moving left and right, that's our x-coordinate. So our focus is actually going to be at H plus C, comma k, and h minus c, comma k. So those are all of our formulas dealing with this particular equation. Now we're going to go to the next equation, the next tab. Here's the picture that we are going to have, and notice the ellipse is kind of a tall one. The last one was a flat one. We're still going to have all the same types of points. So I'm still going to have a center, and I'm still going to have these intersecting lines, my major and minor axis, vertices, co-vertices, foci, all of that stuff still exists, but it's just that it's kind of shifted around a little bit. Now, I told you before that the major axis is always the longer one. That still holds. Minor axis is always the shorter one. We still have our center, and our center is still going to be at HK. Now our focus are always on the major axis, so they're going to be out here somewhere. And our vertices are always on the major axis, so here's our vertice 1 and vertice 2. I'll call this focus 1, focus 2. And then the points on our minor axis, those are our co-vertices. So I'll call it co-vertice 1 and co-vertice 2. So there we have all of our points. Now I've got to start looking at those distances again, and they work the exact same way. To go from my center to my vertice, I move a units, and a comes from that denominator now with the y value. To go from my center to my co-vertice, I go b units. To go from my center to my focus, I go c units. And again, we need to write down that little note that c squared is equal to a squared minus b squared. You need to have that off to the side somewhere. Now go to your next flap, and we're going to fill in this information again, just like we did last time. It's going to be almost the same process, just kind of flipped around. My center, still going to be at HK, and we still have to remember to use the opposite of both, H and K. The length of my major axis isn't going to change at all. It's still going to be 2A. Length of my minor axis, still going to be 2B. Now my vertices, these change a little bit because from my picture, when I look at my center compared to my vertices, this time the x value stays the same and the y value changes. So we're going to have to add and subtract a from the k instead of the h this time. So my vertices are going to be at h, comma, k plus a, and h, comma, k minus a. Co-vertices are going to be flipped around from the last equation. We're going to be switching the x values, so it's going to be h plus b, k value will stay the same, and h minus b, and the k value will stay the same. And then the focus is in line with our x values of our center, so the x value stays the same and we change the y value. So for our focus, we're going to have h, comma, k plus c, and h, comma, k minus c. So those are all of our important formulas that we're going to need for this section. And it's going to take you a little while to get used to using them, but one thing you always want to remember is always identify what H, K, A, B, and C are, because then it becomes a matter of just plugging in the formulas where they need to be plugged into.